Okay, so now we have another very simple question that is based on finding the x bar and y bar, that is the x and y coordinates of center of mass. Center of mass of a system of particles. Sorry, my bad. So now what's given in this question is we've been given a triangle, right? We've been given three identical spheres of each of mass 2m, which are placed along the sides of a triangle, say triangle A, B, and C, such that the mutually perpendicular sides are placed at origin. Okay, taking point of intersection of these two sides as origin, right? So we have ABC, triangle ABC, right angled at A, and this point A is taken to be the origin. So we have what do we have here? We have triangle AB and C, and we need to put A into this origin here. So if we place the given setup into this graph, this is what we get. Now that we have the setup, what can we do? Now that we have the graph, what can we do? We can assign the values of x1, y1, x2, y2, and x3, y3, where these are the corresponding positions of the three masses 2m, 2m, and 2m at each corner of the right angle respectively. Now, what is x1, y1? See, since this is at the origin, x1, y1 has to be 0, 0, right? Now it is given in the question that the other sides are 4 meter each, which means AC should be equal to 4 meter and AB should be equal to 4 meter, right? So if AB is equal to 4 meter, then what should be x3? X3 therefore should be equal to 4 and y3 should be equal to 0. Why? Because there's a point on x-axis. Now if AC, right, if AC here is equal to 4 meter, what would be x2? X2 is a point on the y-axis, therefore it is equal to 0. And y2 will be equal to 4. Why? Because AC equal to 4. So now we have got the coordinates x1, y1, x2, y2, and x3, y3. In which case, what is x bar of center of mass? It is m1 x1 plus m2 x2 plus m3 x3 the whole by m1 plus m2 plus m3. Now given the question that these three masses are same, which is equal to 2m, so I can take 2m common from the numerator, which means the numerator transforms to 2m into x1 plus x2 plus x3. The denominator becomes 2m plus 2m plus 2m, which is equal to 6m. x1 is equal to 0, x2 is equal to 0, and x3 is equal to 4, which means x bar becomes 0 plus 0 plus 4 by 3, which is equal to 0 plus 0 plus, right, we have 4 by 3. Now this is the case with x bar. How do we calculate y bar? The calculations goes the same. Y bar is equal to m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. The mass, all of the masses are equal to 2m, so that becomes 2m into y1 plus y2 plus y3. y1 is 0, y2 is 4, y3 is 0, so that becomes 4 by 3. Now the question here is, the question is to find out the value of root x. So the task here is not to find out the center of mass. But since we have x1, y1, x2, y2 and x3, y3 and the corresponding x bar and y bar, what can we write about the position vector of center of mass? The position vector of center of mass or COM can be written as x bar COMI plus y bar j. What is x bar? 4 by 3. What is y bar? 4 by 3. So what is vector r is equal to? 4 by 3 I plus 4 by 3 j. What is modulus of vector r? That will be equal to root of x square plus y square. What is x square? 4 by 3 square. What is y square? 4 by 3 square. So what we get here is root of 2 into 4 by 3 the whole square, which can be written as root of 2 into root of 4 square by 3 square, which is root 2 into 4 by 3, which can be written as 4 root 2 by root 3. And according to the question, the vector of the magnitude of the position vector is 4 root 2 by x. While comparing these two expressions, what can we say? X is equal to 3. The value of x is equal to 3. Now there is another way. No, well, it's not actually another way. It's just a different approach to to solve this question, which is based on centroid of a triangle.